Sensitivity of the primary mirror. 2.4 m in diameter shows us the most distant galaxies ever discovered. Hubble's observations of the lensing effect have also given us a glimpse of the universe. One of Hubble's core original purposes was to determine the expansion rate of the universe, which astronomers call the Hubble constant. This value is an essential ingredient needed to determine the age, size, and fate of the universe. Before Hubble was launched, the value of the Hubble constant was not known precisely, and calculations of the age of the universe range from 10 billion to 20 billion years. Now, astronomers using data and observations from the Hubble Space Telescope have refined estimates of the current expansion rate of the universe and are working to make it more accurate. Hubble's refined distance values have helped determine the age of the universe to be 13.8 billion years, while improving Hubble constant measurements. Hubble Space Telescope data also aided in the development and use of the cosmic distance scale, an important scientific tool used to measure precise distances to galaxies near and far. The Earth. To do this, astronomers use Hubble to measure the distance to a type of oscillating star called a variable star. It is used as a benchmark. When CF stars are calibrated, astronomers go further out into the galaxy, to nearby galaxies, to use the instruments. Other reliable measurement supernovae stars exploding with the same brightness. Astronomers use X stars to calibrate the relationship between the absolute and apparent brightness of supernovae, a relationship that depends on the distance of the host galaxy from ours. We detect supernovae in galaxies hundreds of millions of light-years away, providing a powerful tool for calibrating redshifts at greater distances than is possible with C-fed stars. However, scientists found that supernovae are at higher redshifts and fainter than predicted when assuming the rate of expansion of the universe is constant, meaning they are farther away. These observations have helped astronomers determine the rate of expansion of the universe over time. Surprisingly, the data showed that the universe is not expanding at a constant rate, but is instead accelerating. Many scientists believe this acceleration is due to something called dark energy, which accounts for about 70% of the entire universe. By observation. How dark energy changes over time, astronomers hope to better understand it and how it might affect the future of the universe. This telescope has also conducted surveys and developed new methods to search for clues about dark matter, another mysterious substance that makes up about 27% of the universe. Astronomers use Hubble to create maps of normal visible matter from which they can determine the large-scale distribution of dark matter by studying how its gravitational presence distorts light in images. Hubble also lifts the veil of mystery surrounding the cosmic monsters that lurk at the centers of most galaxies. These are supermassive black holes using spectroscopic observations. Hubble has peered deep into the cores of galaxies and found that the stars there move in very tight orbits at enormous speeds. This strange behavior suggests the presence of an incredibly large gravitational field that could only be produced by a supermassive black hole. Hubble has provided evidence, the first certainty of their existence. Today we know that at the center of almost every galaxy there is a black hole. Another phenomenon that Hubble instruments have observed over the years are distant quasars. These are powerful jets of energy emitted from extremely bright galactic centers. The energy from a quasar is immense, and they are often thousands of times brighter than the Milky Way. In 1996, Hubble's 100,000th image was of a quasar 9 billion light-years from Earth. More recently, Hubble discovered the brightest quasar ever seen in the early universe. Hubble has revolutionized planetary science in many ways through its precise observations of our solar system. Hubble has tracked activity on Jupiter and its moon, Io. In 1994, Hubble also witnessed a comet impacting the planet's surface. Hubble has also observed auroras on several planets in our solar system. We include Saturn and Uranus. Data from this telescope was also used to study the origin of the smallest known moon orbiting the planet. Neptune, called Hippocamp, in 2013, Hubble provided the first observational evidence of water vapor spewing from the icy surface of Jupiter's moon, Eurasia, near the South Pole. The telescope also collected observations of some special interstellar visitors. In 2018, Hubble studies OMA, the first interstellar object discovered in the solar system in collaboration with other ground telescopes. It was determined that the object was likely a comet and was moving away from the Sun faster than previously thought. In 2019, Hubble provided astronomers with the sharpest and best image ever of the interstellar visitor comet 2 Borisov, believed to come from another planetary system. In our galaxy, Hubble's high resolution has also played an important role in studying the formation regions, stars both in the Milky Way and other galaxies, and its infrared observing capabilities have allowed Hubble to peer through the dense clouds of dust and gas. In those regions, the end of a star can be as beautiful and exciting as its birth. Hubble has observed sun-like stars as they come to the end of their lives in the form of planetary nebula and massive stars that undergo explosive deaths. As supernovae, by studying them at different times in their lives, Hubble has helped us paint a more complete picture of stars, the building blocks of the galaxy. Although not one of its original scientific goals, Hubble has also established itself as an exoplanet explorer, especially through the study of the atmospheres of extrasolar planets. The chemical composition of a planet's atmosphere leaves a unique fingerprint on the starlight that passes through it. By studying the Orion Nebula, Hubble has made the astonishing discovery that at least half of the stars in this region are surrounded by rotating disks of gas and dust, the raw materials needed to form planets. In 2016, Hubble first analyzed the dry atmosphere of a super-Earth 40 light-years away in 2019. In an exciting discovery, the telescope's data was used to detect